Okay, so guys, they have given this value of 13C value in carbon 13 NMR, right? And the value is somewhere around like 220 or 218 picometer, and they have given the compounds also. One compound they have given the alpha pinene, okay, alpha pinene, and the second compound they have given the camphor, okay, and third compound they are given, they have given actually geraniol, and fourth I think was carbon, okay. And they have asked, they are getting this, the signal appears at this ppm, so what compound would be there. So guys, if you see the alpha pinene is alkene, so I am not going to make the structure of this one, right? It is an alkene, and if you have the alkene, then carbon double bond carbon, okay, if you have this double bond, right, if you have this, then carbon double bond carbon chemical shift, it would be somewhere around 130 to 140. So this cannot be your answer, okay. And then you see geraniol is an alcohol, it is an alcohol, and when you have the alcohol, then you cannot have such high value of this one. Now this camphor is having the carbonyl group, and this carbon is also having the carbonyl group, okay. So your option either this camphor or carbon, okay. Out of these two, you actually one of these, one of these two actually could be your answer. Now if you properly see the structure of the carbon, so however it is very difficult actually to learn all these structures, especially when you are not studying the natural product chemistry in detail. So say this is what this is double bond, this is double bond here, and this is carbonyl over there, and this is rest of the part. I am not actually going to draw this part actually, okay. So here you can see the conjugation is there between this carbonyl and between this one. So if you see my video on the NMR spectroscopy, where I have explained the conjugation lowers the chemical shift value, so here conjugation is there, so carbonyl, actually carbonyl resonates somewhere around 220, okay. But due to this resonance, it cannot due to this conjugation, it cannot resonate as, at this value. It should have the lower value than this 222 ppm. So this carbon is also not this carbon can also be not your answer. So what left is the camphor. So camphor actually is the answer. Camphor, you know, it's a very famous compound, and you see it's a bicyclo compound, right? You can draw just like that, okay. Put 2-methyl over there and a carbonyl over there, and this is 1-methyl. So it's a simple, clear, pure carbonyl group, and this carbonyl group resonates as this one. So your answer should be camphor. If you have marked this camphor as the correct option, then definitely you will get 2 marks, okay. Definitely you will have the 2 marks for this problem, okay. And so this is something very, very important, guys, which actually I want to tell you. This question actually is very, very important, and it is easy if you are studying the natural product chemistry in the detail. So these are the some of the questions. I can see what I can have, okay. See guys, one more problem is there. I think the problem number 6. I'm not going to solve this particular problem. The problem is based on the Arrhenius equation. Arrhenius equation. So it's a simple problem you have studied in your class 11th and 12th also, and also in your BSc. And if I'm not wrong, they have given this ratio, K1 by K2, right? This log K1 by K2, they have given this value as 2, and I think they have given the 2 temperature limits. First is say 200 T1, and second was I think 300, okay. This I have written over there, and you have to calculate the activation energy. Okay, so if you know the Arrhenius equation, then it would be easy for you. So you can apply this concept here. Log of K2 by K1, ratio of the two rate constants. Okay, and this is equals to activation energy EA divided by 2.303 of R, okay, multiplied by T2 minus T1 divided by T1 into T2, right? So this was the question, and you have to solve this one. You have to calculate, right? So temperature, two temperatures are given, two values are given. R, you know, this is the gas constant. You can put the value of R, 8.314 joule per Kelvin per mole, just like that. Okay, so you can put this value here, and this is this 2.303 is constant. This value is given. You can calculate this one. But remember, if it is K1 by K2, so you will reverse. See, if the question was like that, I'm not sure whether it was K1 by K2 or K2 by K1. So it will not make any difference. If it is K1 by K2, so you can flip this ratio, and then you will have T1 minus T2 divided by T1 into T2, and by putting the value to solve and by solving this, you can have your answer. Okay, so I'm not going to solve this one because this is actually the pretty straightforward question. And one more question, I think they have asked number of lattice points, number of lattice points they have asked. Okay, in CCP, cubic close packing, and cubic close packing is nothing but it is actually FCC, face centered cubic close packing. Okay, and when face centered is here, then you will have total of 14 lattice points. So answer should be like that, if this option was there and you have marked this one. And if you studied the basic solid state chemistry, then you know, if you have this structure, right, this cube, if you have, then it will have the 8 corners, and in all the corners you are having the points. So total 8 corners, just like that, and 6 faces, 1 2 3 4 5 6 6 faces are there. So 8 plus 6 will make 14. So this could be your answer. This could be your answer, right? I'm not saying that this is the correct answer, but this could be your answer. Okay, and then your next problem, say, question was, okay, this question actually I have solved. The problem number 8 I am writing, that is ground state term. See, term symbol actually they have asked, term symbol for D3 system. So if it is D3, I have solved these problems in my lectures of coordination chemistry, also in Russell Saunders. You can type in the search bar of the YouTube Russell Saunders couplings by tetrahedron chemistry classes, then you will have the answer, right? So but here you see, for this D3 configuration, the answer is 4F 3 by 2. This is the answer. If you have marked this one, then it is 100% correct. Okay, and how we can calculate for this one? See, you are having S, P, D and F, and you are having the L values. Okay, that is 0, 1, 2, 3. Okay, and you can see here 0, 1, 2, 3. Okay, and this is how you can write. And spin, say you are having if you have this system just like that, so I can fill electron, say electron number 1, electron number 2, electron number 3. So all having the same spin, 3, multiplied by 1 by 2, that is 3 by 2. Okay, this is how you can write. And since you are calculating for d orbital, so you can calculate the spin multiplicity. Spin multiplicity is given by 2s plus 1. 2 is this, sorry, 2 you can write in that manner, and you have calculated 3 by 2 and plus 1, so this will make 4. So this 4f is clearly there, and this 4f was there in all the 4 options. Now you have to decide the ground state term. So various combinations are possible for the j values. So I am not actually calculating the j values here, but different j values for this would be 9 by 2 and say 7 2. So okay, I am adding here 7 by 2 and 5 by 2 and 3 by 2. Okay, and this 3 by 2 actually is the most suitable value, j value, so put there. So your answer should be just like that. So this actually, if you have done this question correctly, then obviously you will get the marks. Okay, and then see, this was gone there, and one question actually was there, that is question number 9. Okay, and the question was here, carbon double bond carbon in benzene. So they have asked the bond order. They have asked the bond order and they have given the different options. But this actually question was, and the answer also was in my memory, and the answer for this one is 1.5. Okay, because see, in this double bond, if you see here, if you see this double bond here, right? So one is sigma, you know, and this is partial double bond character. And what is the meaning of the partial double bond character? If it is partial double bond character, it simply means it is having half of pi character. So 1 sigma and half pi, that is 1.5. So one bond order for this is 1.5. Okay, and see next question, what I can write, see number 10, and this question actually was asked by one of my subscriber. They have given the ferrocene, Fe, okay, in that manner, and they are reacting with this sulfuric acid. I think they are reacting with the sulfuric acid. Okay, actually this ferrocene, in this ferrocene, iron behave as the Lewis base, that means electron pair donor, so it can accept the hydrogen from here. Very simple question. If you have studied the reaction of this ferrocene, then it would be, so what you can do, you can write Cp here, and then you can write Fe, and again Cp you can write, okay, and then you can straight away put hydrogen here, H positive. So this was the correct answer. No change in the these Cp rings, right? No change in the, they have given the option in that manner. They have actually changed the Cp, but if you have written this value as such, what you have to do, only you have to put hydrogen here with positive sign. So this is your answer. Okay, and then I am going to take next. And this was the question. right? And see, one more question actually they have asked, that means say I can write the question number 11, and this question is based on the fluxionality. And if you have followed my organometallic chemistry lectures, then definitely you have done this question there. So I have asked this question in that manner. They have given you this complex, iron in the center connected with the two carbonyls, okay, and then you are having the two CP rings. So I will not solve this question completely because I have solved this question in my lecture. You can go through my you can type the fluxionality in the organometallics by tetrahedron chemistry classes in the YouTube. You can get the answer. So recording the spectrum at minus 80 degrees centigrade, that means in that case ring whizzing would not be there. See, 1 2 shift would not be there, not ring whizzing, 1 shift would not be there, and you will have the 3 signals in the proton NMR spectrum. Signals, right? You will have 3 signals. So how you can get the 3 signals for this one? Because this CP ring, I have explained this, so I am not explaining here actually. And see, if you are increasing and going for room temperature, say 30 degrees centigrade, I think they have given, and in that case you will have only one signal in proton NMR as well as in the your 13C NMR. This question I have solved actually. And then the next question, question number, and they have given you these species: sulfite ion, they have given you the carbonate ion, and they have given you this BrF4 negative, and they have asked the geometry of this one. So this question actually is based on the theory VSEPR theory, and these type of questions I have solved in my Vesper theory lecture. You can again search in the YouTube, right, in the tetrahedron chemistry classes. So for this as sulfite is hybridization is sp3 actually, right? This is sp3, and the geometry is TBP, that is not TBP actually, only trigonal pyramidal, not TBP, pyramidal. So I can actually delete this. With sp3 hybridization, it is having trigonal pyramidal geometry. So I can write trigonal pyramidal. And how you can determine this structure, you can go through lectures actually. And then they have given your carbonate ion. Carbonate ion is your trigonal planar. Carbonate ion is trigonal planar, okay, because it is sp2 hybridized. Earlier one, this sulfide was sp3 hybridized, okay, and this is simply your square planar structure. This is your square planar structure, okay. So again you can see this question is very easy question. And then okay, one, see, I will not solve that particular question. They have asked they have given this N2 positive, okay, and they have asked the term symbol for. So term symbol for this is actually 2Eg, or you can write 2 sigma G rate, right? So however, there is a clear-cut method to calculate this one, or unfortunately I haven't made the video on this particular topic, term symbols for molecular species, but you can find in the YouTube, various other YouTubers actually have made the video on this. You can go there, okay. And then I think my last question is, it was based on, see, they have given